How many of you remember a company called DAK or DAC? They had those cute little electronic gadget catalogs that had all kinds of stuff in them, from inexpensive cassette tape decks to answering machines to all kind of gear. I believe they started in the early 80s and went through the early 2000s. They still may be in existence today in some way, shape, or form. If you would have gotten their catalog in the summer of 1991, you would have seen this BSR EQ14/14XR 14-band equalizer on its cover. Now, this guy sold for about $150, which would be about $350 in March 2024. It, as I said, was a 14-band equalizer. It has the nice equalizer display, 14 bands, and it had a pink noise generator, which with the supplied microphone would allow you to level your room acoustics. You had to do it by hand. It didn't use the stuff we have today with computers that will automatically adjust the bands and everything. And I'm going to go into how that works a little later on in the video. It had a few specifications, and I'm going to test how well it did to those specifications. I'll pop the cover off and you can see the circuitry that they used back in 1991 for this guy to a certain extent. That's kind of the scope of this video, and hopefully you will enjoy seeing what this guy actually can do. Here is a close-up of the BSR EQ14/14XR Equalizer. There's a lot going on with it. The most important things are our frequencies that we can adjust up and down are all along here. We can put the equalizer in and out here. We can display the equalizer, or you could use it as an analyzer for the music. And then you can turn on your pink noise here, and you can select inputs. And it does have different memory settings that you could set the equalizer up for, and press one of these presets and go to a different setting, or you could just set it flat if you press this button. We have stuff over here more for the tape monitor and tape recording things, and it does work with a remote, which the window for it is here. And this kind of just gives you an idea of some of its functionality. This obviously is the rear of the BSR equalizer. You can see we have our line inputs and outputs here, and then we have two tape monitor loops here. Here is one view with the cover removed of the BSR 14/14XR. And this is a view from the other angle. The front's right here, and it kind of just allows you to see what's going on inside of this guy. Right now, I am displaying the right channel trace, which is the one made by bypassing the equalizer altogether. So basically, the output cable is going to the input cable of the analyzer, and it kind of just shows the best performance that you could possibly achieve if the equalizer was inserted and was set to bypass, say. Now, I'm going to go ahead and turn on the left channel. The equalizer is set flat across all of the frequency band. We're obviously looking at 1 kilohertz here, but you can see that we've got about 0.63 dB loss going through the equalizer with it set for flat. And you can see our THD is about 0.02%, and the SNR is about 92 dB, we'll call it. So I'm going to go ahead and turn the equalizer on. So now the equalizer is on, but it is set to flat, and it's not in the bypass mode. So you can see that right now we're getting about 1.3 dB of loss going through the equalizer with it set flat, and our SNRs really haven't changed. It's about 91 dB, and our THD has not really changed either. So there's a little bit of difference when you have everything set for flat and you actually turn the equalizer on to where you could adjust some of the controls. I'm going to go ahead and set the 1 kilohertz up to 12 dB, and we'll see how close it is. So I've set the equalizer up to 12 dB. Now you can see that I'm putting a 0 dBV or 1 volt RMS signal in, and you can see how much harmonic distortion we got. The SNR still looks decent, but our THD has gone up quite a bit from I think it was 0.02% to about 0.4%. So if you boost it up to 12 dB, which is showing about 12 dB, because remember we started off at, I think, minus 1.3 dB, so we're maybe 11.6. So it's close enough to 12 dB of boost. I will back it down. So right now I've got it boosted by 6 dB, which would be, let's see, 5 plus 1.3. So it's about 6.3 dB is what it should be, and we're reading about 6. So it's pretty close. THD is nothing to write home about. SNR does not look too bad, but you can just see the level of the second and third harmonics are pretty high, and it just doesn't work real good, at least with 1 volt going into it at 1 kilohertz. I'm going to go ahead and back down that signal a little bit. We'll put in minus 4 dBV and see if it cleans up a little bit. So it does improve. Our THD is pretty decent here. So if you kept your signal down to 630 millivolts, you could get a fairly decent performance going into it. And this is with it having 6 dB of gain. Here is the frequency response of the equalizer, and this is from 20 hertz to 20 kilohertz with a 0 dBV signal applied. Now this top trace is our reference trace, the right channel, and this is basically just the input cable connected to the output cable. And you can see that if we just have the equalizer in circuit, so we don't have the equalizer on, it's just power's turned on and it's in the equalizer bypass mode, and you can see we're down about, we'll call it 0.3 dB here at 20 hertz. And once we get up to about 100 hertz or so, it doesn't look so bad across the rest of the band. It's pretty flat, but it does have an effect if it's just being inserted. Now, of course, it is an equalizer, so you could boost up that frequency if you want a little bit. If we were to put it onto the equalizer is flat mode, but it's on, the frequency response looks just the same. It just changes the relative level here. This plot shows the effect of changing one of the equalizer bands by 6 dB. And note that we're starting off here at about minus 1.3, minus 1.4 dB, which is where we would start off with the equalizer on, but everything set flat. So there's like, I think it was 1.3 dB of loss. So if you add that up, we've got about 6 dB of boost across the band. And we'll just check a few out. Here's our 1 kHz, and it's pretty much at 1 kHz. This purple one here is at 2 kHz, and you can see that it's at 2 kHz. This green one here is at about 60 hertz, so it's pretty close to 63 hertz. So it does seem to boost each of the bands at the appropriate frequency and by the amount of boost that you would expect. This plot shows the system noise of the BSR EQ14/14XR Equalizer. In this case, the inputs are terminated into shorts, and we're just kind of looking at the noise level of the system with everything set flat, and I do have the A weighting applied. The spec is that it should be better than 90 dB, and it looks really, really good. Here is the BSR EQ14's response to a multitone signal. In this case, it translates to a distortion-free range of between 14 to 15 bits. Here's a plot giving a visual indicator of what the harmonics look like with a 1 kilohertz signal applied, and the equalizer is set for 6 dB of boost at 1 kilohertz, and they're pretty darn near close, the even and odd harmonics, at least the second and third harmonics, but it looks like the second or even harmonic is just a little bit higher than the third or odd harmonic. Right now I've got a 1 kilohertz 500 millivolt signal applied, and I've adjusted all the bands on the equalizer to give me between 2 to 6 dB of gain, with the exception of the 1 kilohertz band, which I boosted by 12 dB. And you can see that we've got almost 15 dB a gain with everything. Our distortion is almost 0.5%. SNR looks pretty good at 94 dB, but I kind of just wanted to show that even though the signal is only at 1 kilohertz, there's noise and harmonic stuff that's being affected by the other equalizers being boosted. So now if I go ahead and I drop it so that it's flat, so now I have all the bands set to flat except for the one at 1 kilohertz, which is set for 12 dB. You can see the gain drop down to 10.3 dB. So it dropped about 5 dB, and our distortion improved a bit. SNRs didn't really change much, but that is just the effect of kind of boosting up everything. Right now the equalizer is on the bypass mode, and there is a specification that with a 1 volt 1 kilohertz signal applied, which is where we're at now, our THD should be less than 0.01%. Well, we're at about 0.03%. I'm not going to really care about that too much. And our SNRs are better than 93 dB. THD plus noise around minus 71. And once again, we've got about 0.6 of a dB loss going through the equalizer if you just had it there using it as a spectrum analyzer display. This plot kind of gives you an idea of how THD varies with the input signal level going to the BSR EQ. In this case, it is only at 1 kilohertz, and I've boosted the 1 kilohertz band by 6 dB, and I'm only showing the left channel. The right channel would be similar. And the lowest signal going into the BSR EQ would be about minus 17 dBV, and we come up here to about 8 dBV. Now 1 volt would be 0 dBV, which would be a pretty large signal going into the EQ, and even at that point we're only at, we'll say 0.03%, maybe 0.04%, and even with 8 dBV we're about 0.4% THD. This plot was made with the BSR equalizer set for flat, although it's out, so I guess it really doesn't make any difference that it was flat. And what we're looking at is the THD versus the input signal level and frequency. And at worst case, at lower frequencies, we're not more than 0.1% THD. And once we get to about 50 hertz or so, we're down in the 0.02% THD. And that's just the effect of this guy in the system. For this plot, I had boosted all of the frequencies by 2 dB, and then I varied the input signal level from minus 6 dBV to plus 2 dBV. And so we're looking at the THD versus frequency and the different input power levels. So over here would be 20 hertz, and over here is 20 kilohertz. It looks like we do have a little bit of a distortion problem here with the 2 dB boost. Once we get to about, I would say 25 hertz, it disappears, but at 20 hertz you definitely have something going on there. But once you get beyond that, the THD is better than 0.2%. This plot was very similar to the previous plot. In this case, I boosted every frequency by 6 dB, and then I varied the input signal level from minus 10 dBV to plus 2 dBV, and we're looking at the THD versus frequency from 20 hertz to 20 kilohertz. Basically, it looks the same. It gets kind of nasty right here, and by 25 hertz, it's looking pretty good, and basically it is better than about 0.5% THD across the frequency band. This is a plot of the BSR equalizer's frequency response from 20 hertz to 20 kilohertz. It's hooked in the system, but it's set for out. In this case, you can expect a worst case delta in the frequency response, say from 1 kilohertz, that would be your maximum value, to your minimum value at 20 hertz. You would have about 0.3 of a dB flatness, which is fairly good. The channels are balanced to within, I would say 0.05 dB. This plot right here is what you get when you boost all of the tones to plus 6 dB. You'd expect it would be level. Ideally, everything would be up 6 dB, but it's not the same across the band, or things are adding. But if for some reason you wanted just to boost everything by 6 dB, That's not really going to happen. There are some places where it is boosted by 6 dB or close, but then other places are more, probably because the frequency bands overlap a little bit, but you wouldn't get everything boosted up by 6 dB, I guess is my point. I wanted to show the setup that I'm using to test the BSR 14 equalizer. What I have is a microphone here. Hopefully you can see it. This is a little Audacity microphone. They're probably about $25–30. They're used for testing in-room equalization, and that is pointing towards the Wilson Watt 3 Puppy 2 speakers. Now the equalizer is connected on the external processor loop, which is kind of like a tape monitor loop on the Carver C1 preamplifier, and the output of the preamplifier is going to the Bryson 2B-LP amplifier. You can kind of see the microphone is picking up my sounds as I'm talking. So I'm going to go ahead and turn on the pink noise. Now, before I do that, I will say that this button right here is set for microphone input, or equalizer input is the other option, but right now it's on microphone, and I'm going to go ahead and turn on the pink noise, and you'll start seeing the spectrums varying, and then what your goal is to adjust the gain or attenuation for each of the bands such that the response is pretty much around 0. Now it's going to go up and down because of the variation in the pink noise, but I will go ahead and just kind of show you how it basically does its thing, and I'm going to drown out the pink noise in just a little bit. So right now I'm going to recall memory 3, which is where I put the equalized settings, and you'll kind of see how each of the bands was adjusted to try to get the frequency response flat. So you can see it varies quite a bit as far as what I needed to do to try to get it to optimize the flatness of the pink noise. So right now I have the equalizer out of the system. I'm going to turn on the pink noise generator, and hopefully you'll hear a difference with the equalizer out of the system, and then I'll go ahead and turn it on. So there, the equalizer is turned on and you're hearing its response, and if I remove the equalizer, hopefully you heard a difference in the tone, and that is with the equalizer on, but it's set flat. Here is the frequency response of the BSR 14 equalizer from 20 Hz to 20 kHz following the pink noise generator room correction method, and you can see kind of just how it changed the frequency response across the frequency band. As you saw from the test data, this particular BSR EQ14/14XR equalizer did a pretty good job of meeting its spec. Well, there was really only one spec, and that was the THD with 1 volt applied going in at 1 kilohertz, supposed to be better than 0.01%, and it was 0.03%, so not a big deal there. The noise level of the unit looks pretty good on it, and overall it didn't really cause a lot of distortion, I thought. However, if you start boosting up many bands, and there was a plot that shows it does increase the distortion to maybe as much as 0.5%, depends on how much your boosts are. But when I played around with boosting stuff around, and I looked at the overall distortion now only being measured at 1 kilohertz, but all the other bands were affecting things, yeah, it will put up a higher distortion. But if you're just boosting a few things and taking some down, overall I think it does a pretty good job. If you just want to use it as a spectrum analyzer display and have it just kind of in the system but bypass, so it will show you a frequency display, that is a great use for it. And if you can find one of these, I would recommend getting it. I mean, you have several positions that you can set up for your equalizer that it will remember. Now, it does have a 0.1 farad capacitor in there that it uses to keep the memory. I know that it will hold, at least this one that's, what, 30 years old, would hold its settings for at least 3 days. And I haven't tried it longer than that, but if you had at least a couple settings, they would be good for 3 days if you didn't have any power applied to it. It does have a remote control capability, so there are some universal remotes that would work with this if you couldn't find the regular remote, if that was a feature that you really needed. So overall, I think it does a real good job. It doesn't have any pots that will need cleaning or all that, and it just, you know, has several settings that can be memorized for different equalization situations that you may encounter. So my advice would be, if you were to get one of these or come across one of these or looking for a display, and you know, I would not hesitate to pick it up if you can make sure that it works. There is one caveat that I came across while researching this. There's, I believe, a crystal or a capacitor that can go bad on the front that can cause some issues. But that was really the only problem that I saw with the unit. I would have no trouble recommending this guy. So, of course, the more modern AV receivers that you get today can do all that room EQ stuff automatically, and you know, this one you kind of got to do by hand with the pink noise, and there's some judgment there. You know, it's just kind of a cool thing. So once again, if you like the video, give it a thumbs up. I would like to hear your comments that you may have, of course, and I try to respond to all of them. And if you have not subscribed to the channel, that would be a nice thing to do to help it grow. And as always, until next time, have a great day or night.